First question there. Gavin, would you read it and put your hood down at the same time, please?
Same time. Same time.
As many cylinders with the height of 18 meters, let R represent the radius in meters and V represent the volume in cubic meters. You really gonna do this?
Continue. Continue.
Write an equation that represents volume V as a function of radius.
All right, so remember volume of a cylinder, pi r squared times the height. By now you should have that written many places in your notes. It tells us the height right here is 18. All right, so if I plug that in, 18 for my height. Okay, so 18, and then I'll just leave pi r squared, just leave it just like that. There's my equation. I know my height, so I'm going to keep that in the equation. Just plugging it in for h. That's all it wants for a. I think today's warm-up's asking you to do the same thing. Use this one as a model. Okay, B, complete the table, giving 3 possible examples. All right, so if I plug in 1 here, 1 squared,
Is 1.
1 times 18.
18.
Yeah, I'm just going to leave it as 18 times pi. If you want to do decimal, 50, or no, it'd be 54 point something. Okay, we'll leave it as pi. Then you pick whatever numbers you want. I don't know, let's go 2. 2 squared, 4 times 18, 72. 3. 3 squared is 9, 9 times 18. Yeah, use whatever numbers you want. Plug in 10, I don't care what you use. All right, if the radius is doubled, does the volume double? Well, here we doubled the radius. Did the volume double? No. Why not? Why didn't it? Because we took the radius squared, so it better be 4 times bigger. If we were to graph this, would it be a linear function? Why?
Because every time it gets bigger and bigger by different numbers.
Yeah, points don't line up. And anytime you have an exponent, the graph is going to look like that eventually. Okay, it's an exponential graph. They will not line up. All right, question number 2. Parker, you're up.
Number 2.
Yep.
Can I read it?
Yep.
Part of a competition, Diego must spin around in a circle 6 times and run to a tree. The time he spends on each spin represented by S. The time he spends running is R. He gets to the tree 21 seconds after spinning.
All right, write your equation. Okay, how many times did we spin? 6. And it says use S for spins. All right, 6S. Time he spends running is R. And the total amount of time is 21. There's your equation. Question B. Rearrange so that it shows R. All right, so I'm going to rewrite it again here. Solve for R is what that means. So how do I get rid of a positive 6S? Subtract it. Leave it just like that. Diego takes 1.2 seconds to spin. How many seconds did he spend running? Well, I'm going to plug in 1.2 for spinning time. 13.8 seconds is your answer? Sure. Sounds good to me. Question 3. For which values of x is the output from the table less than the output from the graph? Okay, so for instance, we're looking at 2 separate functions. So if x is 1, I get about 2.2. My table shows me 3. Okay, where x is 2, The graph shows me almost 4. Here it says -1. So when is the output from the table? When are these numbers less than what you see up here? 2, 3, 6, huh? I don't like 6. I think it's just 2 and 3. That's definitely less than -1 up there. Output from the table less than the output. Yep, -1 would not be less than -2 something. So just 2 and 3. In the graph function, what values of x give an output of 0? So where do we hit 0? Looks like 3 times. At 0, at 5, and at roughly 10. Does that look a little less than 10? We're going to call it 10. Cone. Parker, formula for cone.
Cone. Yeah, it's here somewhere. I wrote down V equals 1.
Go ahead. Go ahead. Go ahead.
E equals I R E T H or something.
ETH.
I don't know.
It must be a 2, not E.
I don't know. I wrote E.
E.
Is it an E?
It's just not an E.
That is an E.
See? I thought it was me like mid-reading.
All right. Well, you keep your E, because I don't know what that means.
That's an E.
That is a 2.
1/3 pi r squared times the height. No E, no 78 automatically. But we're going to figure this out once again. Let's take 3 squared times 4 divided by 3. Is that a nice number? Well, 3 squared is 9. 9 times 4 is 36. 36 divided by 3 is 12. 12 pi units cubed is your volume. With an E on it, I guess. Question 4. You have another cone that's quadruple the radius and the same height. Okay, quadruple. What's quadruple mean?
Times 4.
Times 4. So that means our radius is 12. Let's see what the volume is there and see how much bigger it is than the other one. Okay, 12 squared.
Oh,
144.
44.
Sounds like I better do this one myself since you guys are so eagerly getting your calculators out to help yourselves out here. 12 squared is 144 times 4 divided by 3. 192. 192 pi. Okay, so how much bigger is that? 12 times what is 192? 16. Now you also could have said, hey, that's 4 times bigger, right? And you have to square it, so that would have also just told you it is 16 with a lot less work. Either way, if you wrote down 4, you forgot to square it. Radius squared. All right, go ahead and do today's warm-up.